Static equilibrium and dynamic equilibrium are termed when the object is at rest and moving in a constant velocity in a reference coordinate system, respectively. If the net result of all the external forces, including moments acting on an object, is not zero, Newton's second law will apply. In this case, the object of a mass is not in equilibrium state and will undergo an acceleration that has the same direction as the resultant force or moment. The velocity change yields an initial force, which can be quantified by the product of mass and translational acceleration, or mass moment of inertia and angular acceleration.
Hello and hi, my name is Shazrin and today I will talk about the equilibrium of forces but results. As we all know, the lecturers already prepared their students the table of experimental results. So, we have to do an experiment to find or to determine how the result was calculated. But first, we have to calculate the angle. To calculate the angle, we must use this formula. After that, we must kick in the value that already gave in the experimental result. For example, the value of W2 in reading 1, we have 2 Newton, and for W1 we have also 2 Newton. The answer for angle for W1 is 51.3 degree, and also for W2 also 51.3 degree. We continue doing the same things at the other readings. We repeat the calculation 6 times by changing the value of W1 and W2 given at the experimental table. So we just continue and get the answer. Okay. After we calculate the angle of the result, we must find the ratio of the angle and weight by using this formula, which is sin theta 2 over sin theta 1. We call it as ratio of angle, and F1 over F2, we call it as ratio of forces. We just divide the answer to get the ratio, and then we plot a graph of W2 over W1 against sin 2 over sin 1 for experimental and calculated result. So in this section, we have to create two graph which is for experimental and calculated result. After that, we do the graph calculation. The graph calculation contains centroid for experimental, the centroid of calculated results, the gradient of experimental result, and the gradient of calculated results. We do it at the graph because we need to find the percentage of differences between the experimental and calculated results. So my group only get 78% similarity to the experimental result. From that, we can find the resultant of two forces by using parallelogram method and Newton's law of motion to find the resultant force.
A very basic concept when dealing with forces is the idea of equilibrium or balance. In general, an object can be acted on by several forces at the same time. A force is a vector quantity, which means that it has both a magnitude and a direction associated with it. If the size and direction of the forces acting on an object are exactly balanced, then there is no net force acting on the object, and the object is said to be in equilibrium. Because there is no net force acting on an object in equilibrium, then from Newton's first law of motion, an object at rest will stay at rest, and an object in motion will stay in motion. If an object is neither moving through space nor rotating, it is said to be in static equilibrium. The sum of external forces acting on the object must be zero, and similarly, the sum of external torques must be zero.
So next, for the calculation, we just need to put the data that we get from the experiment into the formula. So we just need to put the angle to get the ratio and the weight. Also to get the ratio.
Assalamualaikum, my name is Muhammad Zabib Zainal. My ID metric is CD200-233. Today I would like to present about discussion of report equilibrium of force. First discussion is about discuss the graph obtained. Experiment and calculate result. The graph shown the linearly proportional line for both experimental result and calculate result. For the experimental result, the line of best fit passing through the centroid is obtained and the gradient of the graph is 0.67, while for the calculate result, the gradient of the graph is 0.907, which is approximately equal to 1. This means that the gradient of the graph from the calculated result perfectly follow the rules as stated on Newton's law of motion. There is a difference between the gradient of the graph of calculated result and the experiment result. The percentage of the difference between two gradients are 0.75%. This percentage of difference occur the random error such as parallax error and systematic error during the experiment. Meanwhile, the calculated result assume that no error is occurred. Second discussion is discuss the parallelogram diagram obtained. The answer is the parallelogram diagram obtained show different result which depend of the value of the W2. The length of OB is increased when the value of W2 increase. Also, the angle between the resultant force and OA are also increased when the W2 are increased. On another hand, the length of the OC, which represent the resultant force of the system, is almost similar. It does not show a constant value as there may be same error occurred during conducting the experiment. For instance, systematic error may occur where the friction in the pulley and also the calibration of apparatus such as protector and ruler are not accurate. Besides, random error may also occurs such as parallax error when marking the position of chord. The position of the chord is also one of the random error which will affect the angle and the overall result. The last but not least discussion is make a comparison between experimental and calculated result. There are some similarity and difference between the calculated result and the experimental result. For the value of theta 1 and theta 2, both the experiment and calculated results show that theta 1 is always bigger than theta 2. Also, when the W2 is increasing, the theta 1 is also increasing. For the difference between experimental and calculated result, the ratio of sin theta 2 divided by sin theta 1 and the ratio of F1 divided by F2 is slightly different for experimental result, whereas the ratio of sin theta 2 divided sin theta 1 and the ratio of F1 divided by F2 for calculated result are exactly the same. The reason of the difference between experimental and calculated result is due to the error during the experimental is conducted. One of the error when marking the chord position. Beside this difference may also due to systematic errors such as friction in the pulley, which will affect the accuracy of the result.
So next for the question, for the A, the parallelogram laws of vectors give us the mathematical ways to find the magnitude of the resultant of the two parallel forces by using the Pythagoras theorem or the cosinus rules. So for the question B, the alternative method that we can use is by using the free body diagram analysis. By using free body diagram analysis, the net force was either horizontal or vertical.
Assalamualaikum and hi, my name is Nur Fatiliana binti Wad Khairul Anwar. Matrix ID CD200 and 209 from section 4. I'm in the part of conclusion in this report. By the following question given, I would like to express that the law of parallelogram can be used to express the resultant force of any forces in a parallelogram. To avoid random error, it should be measured at least 3 times at the same angle to get a precise reading. Last but not least, in order to eliminate random errors, we must make significant contribution during the experiments and ensure all supplies and equipment are in good functioning order. Lastly, this type of precaution will help to decrease the number of mistakes that may arise throughout the trials. Thank you.